Hi friends, welcome to estudy.in. So in this video, we'll be talking about what is compilation, and we will understand the meaning of compilation in general, and then we will discuss compilation, Java compilation process, and how it is different from ordinary compilation. So before we start, don't forget to click on the subscribe button if you have not already subscribed to the channel, okay, so that you keep getting the new videos which I post. Okay, so let's start. Let us understand the meaning of compilation. Now, what is compilation? And before we start with actually understanding the Java compilation process, there are a few terms which you should be very comfortable with. First is, what is compilation? What is the general meaning of compilation? So generally, compilation basically means the process of converting source code into machine code. Okay, the process of converting source code into machine code. Now you must be wondering, what is source code and what is machine code? So source code, it is a program which is written in a programming language like C, C++ or Java. So when you write a program using any of these languages, that program would be the source code. And since the computer cannot understand this source code, it has to be converted into machine code. What is machine code? It is a machine language which consists of zeros and ones. So that means, because the computer only understands the machine code, it does not understand source code. So every source code that you write using any programming language has to be converted into machine code, and this process of converting source code into machine code is called compilation. Now another thing which you should be comfortable is the file name. Now you must remember that every file name has got two parts. One is the name of the file and second is the extension of the file. Now both are separated with a dot or a period. So if you see this file list.doc, here list is the name of the file and doc is the extension. So every file that you create will get an extension according to the software which you used or the program which you used to make the file. So if you have a file list.doc, most probably you made it in Word. Okay, now if you see the second file samples.xls, this is an Excel file. Okay, here samples is the name of the file and the part which comes after dot is the extension of the file. Similarly, we have another file here, test.exe. exe stands for executable file and test is the name of the file. Now if you create a file using Java language, then the extension of the file would be .java. That means the part after extension, that is the extension of the file, is .java and hello is the name of the file. So this would be the source code. That means when you create a program using programming language, Java programming language, then the source code will have the extension Java. Okay, .java. This you need to remember. Now let's move on and understand what is ordinary compilation, and then we will discuss how it is different from Java compilation. Now ordinary compilation, that means when you write a program in any other language, for example maybe C, C++, then what happens is, when you create your source code using any of the programming language, what will happen is, once you make the source code, you have to convert it to the machine code. Okay, so for converting it to machine code, as I told you earlier, you would need a compiler, because we need to compile it. Okay, so for compiling the source code, we need something called compiler. Compiler is a software. Okay, so that compiler would convert the source code into machine code. Now let's suppose we have three different types of machines or three different types of computers. On one computer we have operating system Windows, on another we have Linux, and another computer is Mac. Okay, so what happens is, when you write the source code, and the same source code, if you're working on a Windows machine, you will have to compile it for that Windows machine, and then that means you need a compiler for that Windows machine, and then it would be converted into machine code, which is called executable code. Now this executable code is only for Windows, and if you have to run this program on another machine on which maybe you have Linux or you have a Mac, then you need a separate compiler for that machine. That means the same executable code will not run on these two machines. So that means we need to compile or convert it as per the platform. Okay, so the same source code, we need a different compiler for Mac, and for the same source code we need a different compiler for Linux. So that means at the end of it, we have three different machine codes which are called native executable code. So that means for Mac I have a executable code 1, for Linux I have a executable code 2, and for Windows we have executable code 3. So for the same source code, that means one source code, we have three different versions of machine code. So that means my executable code for Windows will not not run on Linux or will not run on Mac. Similarly, the executable code, that means a program which was created for Linux, will not run on any other machine. So this is the problem with ordinary compilation, that your code is not portable, as we say. Portable means it cannot be carried out to different devices or different operating systems. Okay, so when Java came, Java solved this problem, and that is why Java is called a portable language or a platform independent language. Now let us see how Java compilation process is different from ordinary compilation. So this is Java compilation. Now let us understand what is happening here and how you will see the difference here. You see, again here we have hello.java, which is the source code, just like previously we had. Now when you compile this source code, you do not get an executable code. Instead, we get something called bytecode. Now this bytecode has the extension of .class. See, the source code has the extension .java and the bytecode has the extension .class. So that means when the source code, when Java source code is compiled, we do not get executable code, we get something called bytecode. The extension of the file would become hello.class. This class file is called the bytecode. Now this class, this bytecode is passed on to another software which is called JVM. We will understand JVM a little later, but as of now you need to understand this, that this bytecode will then be passed on to JVM, which will further on pass it to operating system and which will interact with the machine to give you the output. Okay, so this is how the Java compilation process is working. If you see, previously we did not have this JVM. We had different compilers for different machines, and creating a compiler, that means which is a software, is expensive in terms of time, in terms of resources, various other resources. Okay, so that is why it is not easy to create a compiler for different machines. Now when we see here, we have done away with the executable code. Instead, after compiling a source code, what we get is a bytecode. This bytecode is passed on to JVM, and then JVM will give us the output after passing it to the operating system. Now let us understand what is JVM. Now the full form of JVM is Java Virtual Machine. Okay, it is not actually a machine. Only the name has the word machine. It is actually a very small software. So it is called an interpreter for bytecode. Now what is interpreter? Interpreter is something which will, just like we have a normal interpreter is somebody, it's an in-between which will convert the source code into machine code or line by line. Okay, so we have this bytecode and it is an interpreter for the bytecode. Okay, that means line by line it will interpret the bytecode and convert it into further machine code. It is a platform dependent. Now we are talking about JVM here. That means JVM is platform dependent. Every operating system will have its own version of JVM. That means the architecture of JVM will vary for different operating systems. That means for Windows I'll need a different JVM, for Mac I'll need a different JVM, and for Linux we will need a different JVM. Now let us understand this a little further. So what we have is, we have a source code here, hello.java, and we compile it. This compiler is called Javac. Javac is a Java compiler. When you compile it, what do we get? We get a bytecode, which is a class file, .class file. .class file is called the bytecode. Now this bytecode will run on different platforms. We need not compile it again and again. It will run on every platform, provided that platform has the JVM. So for Mac, I will need a different JVM. For Windows, the JVM is called JRE, Java Runtime Environment. And for Linux, we will need a different JVM. So what we are saying is, Java is a platform independent language, because once we get the bytecode, this bytecode will run on all the machines or all the different operating systems, provided each operating system has its own JVM. So JVM, the architecture of JVM varies from platform to platform. So that is why we are saying that JVM is platform dependent. Okay, it will vary from platform to platform, but Java is a platform independent language because it is portable. We can port the Java bytecode onto different machines, and we just need a JVM for each machine. Now, JVM is a very small software compared to compiler, which, as I told you earlier, is difficult to create in terms of it is expensive in terms of time, in terms of resources. But JVM is a very small software and it can be easily made for different platforms. So this is how Java compilation process differs from ordinary compilation. So I hope you like the video, and please don't forget to click on the like button, and please do subscribe to my channel estudy.in and keep watching estudy.in. Thanks for watching.